All right, folks, we're trying to find a percent error here. So here's how to do this. In an experiment, you measured 3.80 grams for something. I don't know, what did you say? You measure the mass of a product of a chemical reaction to be 3.80 grams. According to your theoretical calculations, you should have gotten 3.92 grams. What is the percent error of your work? Essentially what percent error is we're asking how far off from the actual number did you get? And in order to find the percentage of something, percent, you always take the part divided by the whole. So I guess the question is, how far off did you get? Now, the formula that you go is O minus A divided by A. And I've seen teachers teach it like this, and actually it's wrong. But I'll explain to you what's going on. So the O is your observed. I don't like O because it could be original, but no, it's your observed minus the actual or accepted value, and then divided by the accepted value. And our number is what we observe is 3.8, and it should be 3.92. So we got a number that's smaller than the actual number. So that when you take the number and minus it by a bigger number, or you're going to get a negative. And so you're going to get a negative percent error, which basically is saying, hey, the measurement that you got was too small, as opposed to like a positive percent error, which means the measurement that you got is too big. Now, when another person told me that that's the way their teacher taught it to them, it really kind of, I was like, that's not really how it works, because what needs to happen is you need to have an absolute value around here. And in that way, because what we're doing is we're measuring how far off from the original. We don't care whether or not you measured too high or too low. We just want to know how far away did you get. So that's why we put the absolute value in, because it doesn't matter whether or not you got a positive or negative number. You just want it to be a positive number because you want to know how far away did you get. And I guess I don't even really like this formula that they gave us. I like really understanding what percent error is. If I want to figure out, first of all, if I want to figure out how far away I got from the original, what I should do is I should take a difference. Right? I should find where I started, or where I ended up measuring, and where the measurement should be. So that's why I have the O minus A, or 3.80 minus 3.92. So 3.80 minus 3.92, that equals 0.12. Now, that's not really going to help me much. Oh, also, this is measured in grams, and a percent error doesn't have any units, so that's not going to help me much, because 0.12, is that a lot or little? Well, you want to compare it to something, and so that's why you divide it by 3.92 grams. That was the original, or the actual measurement that you got. That's why I have the A down there. All right, and then also notice that the grams cancel out with the grams, and you're left with just some number that is a unitless number, and a unitless number can also be a percentage. So if we use our calculator, we got 0.12 divided by 3.92, and you end up getting 0.0306. 0.0306. Now, that is not a percentage, that's a decimal number. And in order to make it a percentage, all you got to do is move it to the right 2 times. So the percentage that we got is 3.06%. And that would all work if you plug it into this original formula. In fact, I just basically explained to you what the original formula was. So you can memorize the formula, you can always look it up, but I would really memorize the concept. That will get you further, because when you take a test, you won't have the formula out in front of you, but you will be able to memorize the concept, and maybe that will help remember exactly what to do.